Hello all, welcome back. And today's topic is Strasson's formula. Normally, Strasson's formula is used for finding the matrix multiplication result. So, before going into this, we should know what is a matrix and what is matrix multiplication and what is the time complexity of matrix multiplication. So, after seeing all those, then we'll come to Strasson's formula and how we are getting benefited with the Strasson's formula for performing matrix multiplication. So what is matrix? Matrix means it is a two-dimensional array. Generally you can say a matrix is a two-dimensional array. Okay, so which consists of rows and columns. You can see a matrix here. Here I have a 4 cross 4 matrix, which means in these two matrices I have 4 rows and 4 columns. Okay, so this is what called as a 4 cross 4 matrix. So when a matrix contains 4 rows and 4 columns, then you can say that matrix is a 4 cross 4 matrix. Here there are two matrices. Both the matrices has 4 cross I mean 4 rows and 4 columns. So how can we write this matrix? I can write this matrix as A of 4 and 4. So here this is the two-dimensional array, and here I have given a name for this two-dimensional array as A. You can see the number of rows is 4 and the number of column is also 4. Okay, so this value represents the row and this value represents the column value. In the same way, I can write this matrix as B of 4 comma 4, which means the matrix, this matrix is taken as B matrix, which consists of 4 rows and 4 columns. So this is what a matrix, which is containing which is containing rows and columns. Then what is matrix multiplication? So matrix multiplication means it is a binary operation where you are going to multiply two matrices and you will get a resultant matrix, which is a single matrix. Okay, so here is an example for that. You can see I have two matrices. One is A matrix and the second one is B matrix. So I'm going to perform multiplication on these two matrices. Okay, and the resultant matrix is my C matrix. So here I'm multiplying two matrices and the resultant matrix is a single matrix. Okay, you can see there are two rows and two columns in this A matrix. Again in B matrix also I have two rows and two columns. So the resultant matrix will also have what? Two rows and two columns. Okay, so one more thing, when you're going for matrix multiplication, you need to know one condition, that always the first matrix column should be equal to second matrix row. Okay, so for example here this matrix is a 2 cross 2 matrix and this matrix is also 2 cross 2 matrix. So this is the column value for this matrix and this is the row value for this matrix. Always this column and this row value should be same. If in that case you can go for performing matrix multiplication, otherwise you cannot perform matrix multiplication. So I'll tell you why, what is the reason. Because see, this is the formula we use to perform matrix multiplication. If you look at this formula, what you're doing here, actually when you're performing matrix multiplication, you will consider the first row of this matrix and then you will consider the first column of this matrix. Okay, then you will perform multiplication along with the addition operation. Okay, again when you are like based on this only, you are going to generate the first value in the resultant matrix. Again coming to this value, so how do you perform C12? Okay, again what you are doing means you are going to consider the first row of this matrix and this will be multiplied with these two values, that is the second column of the second matrix. Again these values will be added up and the result will be given here. Okay, so this is how matrix multiplication is happening. You are going to consider the row values of your first matrix and column values of your second matrix and you are performing multiplication along with addition operation. Then you are producing the result of like matrix multiplication. Okay, so I have written this in this formula. Right, in the formula, like if you see C11, how do you calculate C11? By multiplying A11 with B11 and then add then A12 with B21. Okay, so first column value, first row value and first column value. So this will gives you the result for C11. And then coming to C12, how do you obtain C12? Again by taking this A11 first row, A11, but multiplied with the second column value, that is B12. Okay, so A11 multiplied with B12 plus A12 multiplied with this B22. So by this we will obtain the value for C12. Same way, if you take C21, here now you need to consider the second row of this first matrix. Okay, again go for first column of the second matrix. So A21 multiplied with B11 plus A22 multiplied with B21. Right. So again for C22 same, A21 multiplied with B12 plus A22 multiplied with B22. So this is how you are going to find the matrix multiplication. Right, and this is an example for 2 cross 2 matrix. Okay, now if you look at this example carefully, so here you need to find the value for C11. So what is the formula generally I can write here is, let me take this value as I and this value as j. So Cij, that can be given as first A, and you can see 1, so like I am taking this as I. Okay, and this value I am taking it as k. Okay, you need to use an intermediate value here, k. And then B, this is also K, and this one is J, plus, and here also same, A, okay, I, and then this is also J into, sorry, it is K, again B, K, J. Right, if you apply all these values here, then you will obtain this general formula. If you take this one also, here I value is 1 and J value is 2. You can see here AI, so AI 1, and then this one is nothing but an intermediate value you are taking here, that is K. Okay, then coming to B also, first you have K value is 1, again what is the J value? J value is 2. Okay, plus again A into, now what is the I value? 1, and what is the intermediate value? That is 2. Again B, what is the intermediate value? K value 2, and then J value is 2. Okay, so you can write these formulas in general like this. Right, now based on this we are going to write an algorithm for this matrix multiplication. So how do we write algorithm for matrix multiplication? Here is an algorithm, you can see. See, in this algorithm, first I used what? For loop. And how many for loops I'm using? So 2 for loops I'm using. Why am I using 2 for loop? Means here I already mentioned that a matrix is a 2-dimensional array. Okay, when you are using 2-dimensional array, in order to access the elements of that 2-dimensional array, we need to use 2 for loop. First for loop is for representing the row value, and the second for loop is for column, indicating the column value. Okay, here this variable I and j is used to indicate the row and column indexes. Okay, and now coming to the inner for loop. If you take the inner for loop, here I have used an inner for loop which contains the variable k, and this also starts from the index value 0 up to less than n k plus plus. So why am I using this in one more for loop, that is third for loop? Means, as I have mentioned you here, whenever you are performing the operation, you are using an intermediate value, right, for multiplication. So for that reason, here I have used one more for loop which is having the variable k. Okay, and this is the formula for finding the matrix multiplication. Okay, initially you are taking C of I comma j as 0. Okay, and then you are going to perform multiplication, then you will be adding it with that C value, corresponding Cij value, right? So this is what the algorithm for matrix multiplication. Now with this algorithm, how do we find the time complexity? So if we want to find the time complexity of this type of algorithm, generally we'll go for this for loop, okay, and we'll check how many times this for loop will get executed. If you look at here, you are going to execute this for loop from 0 up to n. So how many times this for loop will get executed? It will get executed for n number of times. Again, next coming the Next coming to inner for loop. This inner for loop will also gets executed for n number of times. Again coming to the next inner for loop, this for loop is also getting executed for n number of times. So you can see this for loop execution n time is taken, and for this execution also n time, and for this also n time. So totally how many times it is taking? It is taking n cube times totally to execute this complete algorithm. Okay, so the time taken is order of n cube for this matrix multiplication. So this is the time complexity when you are generally performing a matrix multiplication. And how do we apply divide and conquer technique for doing this matrix multiplication? Okay, because this Strassen's matrix is one of the example for divide and conquer method as well. So how do we apply divide and conquer for matrix multiplication? Here I have taken two matrices. So A matrix, which is again 4 cross 4 matrix, and coming to B matrix, this is also 4 cross 4 matrix. Okay, so this matrix is actually a larger in size. Okay, this is a larger matrix. So what could be the smaller matrix that can be taken for multiplication, which is 2 cross 2 matrix. Okay, because that contains only 2 rows and 2 columns. That will be the minimum size of the matrix that we can consider for performing matrix multiplication. But here the matrix size is 4 cross 4, which is larger here, right? So in that case, how we are going to apply divide and conquer technique here means we are going to divide the like rows and columns in the given matrix. So you can see here I have divided the rows and columns of these two matrices. Okay, by considering the smallest matrix in this matrix. So this is my smallest matrix, which is 2 cross 2. Again here I have one more smallest matrix, which is again 2 cross 2. Likewise, I just splitted this into 4. I divided this into 4 matrices. Okay, again this B matrix is also divided into 4 sub matrices. So totally I formed 8 sub matrices by dividing this matrix by n by 2. Okay, so this is what I have done by applying divide and conquer technique for matrix multiplication. So after you divided this matrix into sub matrices, then you can solve these sub matrices. Okay, after finding the result for sub matrices, then you can combine these matrices together to get the desired solution for this original matrices. Okay, so here this sub matrix is considered as A11 and this sub matrix is considered as B11. You can perform multiplication on these two sub matrices. Okay, then you can find the result. Same way here this sub matrix A12 and this sub matrix B12 is taken as the another sub matrix, and you will be performing multiplication on these two. Okay, same way you have to perform multiplication on all 4 subdivided matrices. Okay, and what would be the time complexity for this method? That is, after applying divide and conquer technique, what would be the time complexity? Here also the time complexity will be same as like the previous one, that is order of n cube. How? So we have the recurrence relation here. If you look at this recurrence relation, as I said, we just divided the matrix. Okay, and how we are dividing it? 8 into 8. So what is the time taken here? It is n divided by 2. Okay, so 8 into t of n divided by 2 plus what is this order of n square? So this order of n square means this is the time taken to combine your matrix, like for performing addition. Okay, not only you're going to do the multiplication here, but also what you're going to do, you're going to add the elements into the array, because you divided the given matrix into sub matrices, right? Now again you need to combine all those sub matrices by performing addition operation. So here this is not a normal addition operation, because you are performing matrix addition here. So when you are performing matrix addition, again it is a 2-dimensional array addition. So when you are taking 2-dimensional array, there you need to use 2 for loop to perform addition of 2-dimensional array. So when you are using 2 for loop, again the time taken to execute this for loop will be n, and the time taken to execute the inner for loop will be n. In that case, the total time taken to execute that particular addition, matrix addition, would be n square. Okay, so that is why you got order of n square, right? So when you solve this recurrence relation, you will get the time complexity as order of n cube. Okay, this is what the time complexity when you are going for divide and conquer for matrix multiplication. In order to overcome that drawback, in order to overcome that time complexity order of n cube, so here Strassen has discovered some way for computing the matrix multiplication. Instead of going for performing multiplication operation and then addition operation, here we have reduced, he has reduced number of multiplications and number of additions and subtractions. Okay, and in this formulas you are going to use only 7 multiplication and then 18 addition along with subtraction. Okay, you are going to do only this type, like this operations here, so which is which reduces the time complexity here. And these are all the formulas. Okay, so by using these formulas you can perform the matrix multiplication instead of finding the result in the previous way, like considering the first row and then the first column of second matrix, performing multiplication and addition with those values. So what you are going to do here is you are going to use these formulas. If you want to find the value for C11, here you have P plus S minus T plus V. Okay, so if you do this, you can find the answer for C11. And what is this P? This P is given here. What you need to do for P? So instead of performing multiplication, you can see here. So you have performed addition operation 2 times and multiplication for 1 time. But in general, what we will do? We will perform multiplication for 2 times and we will perform addition for 1 time. So compared to multiplication operation, addition operation will take only less amount of time, right? So that is the reason here also in this Strassen's matrix multiplication, the time complexity is slightly reduced because of reducing the number of multiplications and increasing the number of additions or subtractions. And then the same way, if you want to find the value of S, that S value can be given with this formula. And now coming to T, T can be given with this formula. And V can be given with this formula. Okay. Likewise, you have this 7 formulas. So P, Q, R, S, T, U, V. So totally 7 formulas are there. By using this 7 formulas, you can find the matrix multiplication result. Okay. And what would be the time complexity when we are using Strassen's formula? So here is the time complexity. And this is the recurrence relation for Strassen's matrix multiplication, where I told you that you have only 7 formulas. So you have divided that, here also you are applying divide and conquer method, because if the matrix given is a larger in size, then you can apply what? Divide and conquer method, and then you are going to apply the formulas here. So 7 T of n divided by 2 plus this order of n square is same because you need to combine it by performing matrix addition. So here you are having the same order of n square. So if you apply Master's theorem for this recurrence relation, then you will obtain this as the time complexity, which means n power log 7. So the value for n power log 7 would be n power 2.81. So instead of order of n cube, you just have reduced the time complexity to n power 2 power 81. Sorry, n power 2.81. You can see the time complexity is slightly reduced in this Strassen's matrix multiplication. So this is one of the applications of divide and conquer method.